Hello class, so we have learned all of our factoring methods that we are going to do in Algebra 1. So I have this flowchart that is put together for us. We are not going to do this 4 terms grouping. We don't do that in Algebra 1 anymore. Alright, so we're going to talk about what we need to do when we need to factor a polynomial. So the very first thing you need to do always is look for a greatest common factor. If there is anything that you can pull out, we will pull that number or those letters out before we begin any of these other factoring techniques. Alright, so after you look for a greatest common factor, if we have 2 terms left, so if we have 2 terms left, the only thing we can look for is a difference of squares. Alright, so when we have a difference of squares with just those 2 terms, we first need to make sure we actually have a difference of squares, and remember we do that by making sure we have that subtraction sign and that we can square root both terms. So once that is done, we know we can do that. We're going to follow the factoring rule of a squared minus b squared will give me a plus b times a minus b. And then we can always check our work by distributing. So let's look at our first example on this PDF. We have x squared minus 64. So first we need to check we have our subtraction sign, so we are good on that piece. Can we square root both terms? So if you remember, when we take the square root of x squared, the square root is undoing the square, we get x. What about the square root of 64? What does that give us? So that will give us an 8, because 8 times 8 gives us 64. So now that we can take the square root of both terms, we can plug them in to our rule here. So our first term was x. Our second term is 8. So I have x plus 8 times x minus 8. So that is our answer. We can check our work by distributing. I'm not going to do it on here to save some time, but it's a good rule to always check your work. All right, our next example, we have 18m squared n minus 2n cubed. So if you notice, we actually have a greatest common factor we can pull out here. So a 2 will go into both 18 and 2. But they also both have an n in the problem. So we can also pull out an n. So once we pull that out, we are left with 9m squared minus n squared. But we can't leave that greatest common factor out, so we write that on the outside of the parentheses. Not a 24, a 2n. All right, once we do that, what's left inside of the parentheses here, so this 4m squared minus n squared, we have 2 terms, so we need to check if we can do a difference of squares. So we have our subtraction sign, so we are good on that piece. Can we square root both terms? So I'm going to come out here to the side. The square root of 9m squared. So the square root of 9 is 3. The square root of m squared is m. So we can take the square root of that term. And then can we take the square root of n squared? Yes, we can. That is undoing our square, so we are left with just an n. So now we'll take and just plug that into our factor rule up here. So we have 3m plus n times 3m minus n. And that 2n has to come down with it or it is not equal. All right, so that is if we have only 2 terms. So now we're moving on to if we have 3 terms. So if we have 3 terms, more importantly, if we have 3 terms and we have a 1 in front of our x squared, we can find our factors that will multiply to C, our last number, and add to B, the middle number. So we're trying to find two numbers that will multiply to our last number and also adds to our middle number. So when we look at our first example, x squared minus x minus 42, again, remember, we're supposed to check for a greatest common factor. This one will not have a greatest common factor because we have ones in the problem. When we divide by 1, it doesn't change anything. So now we go into our next part. We need to figure out what multiplies to give me C. So in this case, what multiplies to give me a negative 42? So I'm going to start by just writing out what gives me 42. So I have 1 and 42, 2 and 21, I have 3 and 14, and 6 and 7. So all of these will multiply to give me a 42. But remember, we want a negative 42 because we have the minus sign there. Here in the middle, since we have a minus sign, that tells me my larger number is going to be negative. Because when we add, we want a negative number. So we take the sign of the larger when we add. So I'm going to add a negative number to all of my bigger numbers in the factors. So I am looking now. I have my factors of C. I want to know which one of these will add to my B value. So my B value here is a negative 1. So if we do this math, 1 minus 42 will give me a negative 41. 2 minus 21 gives me a negative 19. 3 minus 14 gives me negative 11. 6 minus 7 gives me negative 1. So I know my factors are going to be 6 and negative 7. So once we do that, we plug it into our x plus a number. So x plus 6 times x plus another number. But instead of doing plus, I'm going to do a minus because x plus negative 7 will change to a minus 7. All right, looking at our next one, we have 2w squared plus 20w plus 50. So in this case, we need to look for a greatest common factor because we don't have 1 in every term, or in any of the terms. So I have a 2, a 20, and a 50. The biggest number that will go into each one of those is 2. So I'm going to divide each of these terms by 2. And we won't divide by a variable here because each term doesn't have a variable. They don't all have a w in it. So when I divide by 2, I'm left with w squared plus 10w plus 25. And we put all of that in parentheses with our greatest common factor on the outside. All right, so now we want to find our factors of C. So what is C? That's right, my C is 25. So my factors of C are 1 and 25, because 1 times 25 is 25. And also 5 and 5. 5 times 5 is 25. All right, once we have all those picked out, we want to know which will add up to B. So which of these two sets of numbers will add to my B value of 10? So 5 and 5 will add to 10. So now I have w plus 5 times w plus 5 with that greatest common factor of 2 on the outside. You may also see this written because w plus 5 times w plus 5, they're the same things. So you may see this as w plus 5 squared with our 2 on the outside. So this is probably the most common way you will see this. All right, so we have learned one more way of factoring, and that is if we have a number in front of our x squared. So we called this the slip and slide method. So first look, do we have a greatest common factor? Is there any number that will go into 3, 27, and 6? So 3 will. So we can divide each of these by 3. And then we're left with 10x squared minus 9x plus 2. And don't forget that greatest common factor on the outside. Alright, so now we need to do step 1. Slip a to the end and multiply it by c. So my a value is this 10. We're going to take the 10 to the end and multiply it by 2. So we come over here to the side to work so I don't run out of room. So on the inside, I'm now going to have x squared minus 9x plus 20. All right, we're now going to factor this just like we did when we had a normal trinomial. So what multiplies to c and adds to b? So my factors of 20 are 1 and 20, 2 and 10, and 4 and 5. And since that's a positive 20, but over here we have a negative 9, that means my terms have to be negative. Because a negative times a negative gives me a positive. But to get that negative 9, we have to add two negatives together. So what will give me a negative 9 out of these 3 factors? The negative 1 and negative 20, the negative 2 and negative 10, or the negative 4 and negative 5. So good, the negative 4 and negative 5 will give me what I'm looking for. So I'm going to rewrite this as 3 times x minus 4 times x minus 5. All right, then we need to go on to step 3. Divide both of our factors by the value we slipped over in step 1. So remember, we multiplied by 10, so now we need to divide by 10. And then on to step 4, we need to reduce our fractions. So I'm going to come over here. I'm going to reduce 4 divided by 10. That gives me 2/5 when I reduce that. And 5 divided by 10, that will give me 1/2 when it gets reduced. All right, so now that we've reduced it, we need to slide the denominators up to the variables. So my denominators are the numbers in the bottom, and we're just going to move it up to the x term. So now we have 3 times 5x minus 2 times 2x minus 1. And just like any of these factoring problems, you can check your work by distributing. I'm not going to do it here to save time. All right, so those are the ways that we have learned how to factor. We are going to do some practice on it, so make sure you are paying attention and following these steps and noticing how to figure out which way to use and when. If you have any questions, let me know.